Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz, and I'm your host. And today we are going to talk about content that I don't really know a ton about: meshes and gradients, advanced graphical techniques. By the way, I was off for a few weeks. I was traveling to visit family, and I was in New York for FlutterCon, and then I was lucky enough to go to Korea for some other Flutter events. And so it's just been a while since I've been in the captain's chair here, but I'm excited to be back. I don't currently have any other travel scheduled for the rest of the year. I'm very excited to not go to airports. So Observable Flutter should be more regular through the rest of the year. But anyway, let's stop talking about my calendar and get into meshes and gradients. So as you all may recall, this is the Flutter community. So let's live up to our own good name, at least in our own minds. We like to think of it as a good name. And today's guest is none other than Renan. You all know him as probably the most prolific graphics person in the Flutter community. There are certainly others who post some pretty darn cool graphic stuff on Twitter, but for my money, Renan is the leader in the clubhouse for all the neatest stuff. So without further ado, I have a very smooth brain, no wrinkles anywhere to be found. Without further ado, Renan, welcome back to Observable Flutter.
Hello there. Thanks for the generous introduction. There are lots of people with lots of knowledge, and Flutter is so big, even in graphics terms, that I like to think that Jonah Williams is the goat of Flutter graphics, because he's working on the impeller stuff, and that's some weird things going on there.
Yeah, certainly it's hard to compete with the engine team, the impeller team, Jonah, who works on the engine and the actual graphics layer of Flutter, Brandon, who works on the 3D stuff, Chinmay, who is the mathematical genius behind impeller. Yeah, I mean, certainly if we're including those fellas in the conversation, then nobody's on the medal stand except them. Oh, and I accidentally
I'm back.
Removed you from the stage, but you're back. All right, so today you've got some meshes, shaders and meshes and gradients, or whatever was on the title screen. Now, you were here before, and that one was actually about shaders. Yes, no, this one is just meshes and gradients, not shaders. Can you set us up with maybe what kind of stuff we covered in your last visit, and what we're going to do today?
Yes, sure. If you can put my screen up, I can put some more context into it. So last time I was here, I think it was about the same time last year, October 2, right?
Something like that.
Yeah, and I showed this was an experiment that I ran. So it's basically combining the power of fragment shaders on Flutter and also Flame. And recently on a talk I gave in Flutter and Friends about WASM, this was also a test bed. So the reason I use this as a test bed for a talk about WASM is just because it's so there's so much going on in terms of graphics here. So I think it's a nice benchmark for performance. And yeah, so this is, you can access in this URL. Of course, I'm running here on Firefox, so it's not running on WASM. But if you access with Google Chrome, you will see WASM running with this game. So last time I was just covering what I did and what I had to do to achieve this effect. And there is a connection to what we're going to talk today. It's not on this demo, but on the demo that I showed last year. There was an implementation of a fragment shader. And yes, people, this is all Flutter. Almost everything I'm going to show here today is all Flutter. And this is also open source on my GitHub. I have to put the link. I can send you the link later. But yeah, the source code is all available for people to try out. And what's happening here is like you have lots of layers, and you apply shaders to different layers. And it's running on Flame, the Flame engine that just made 7 years this week, just like Flutter did 10 years this week, right?
Yeah, pretty wild. By the way,
Crazy.
Ayushman, I'm also amazed, but note that I didn't write a single line of this, nor barely can comprehend how it works. So Hanan should be the recipient of our amazement. Yeah, you said it was you said this was open source. Can you maybe share your GitHub?
Yes. Renan.gg, which is my website, has links for everything. And there's links for Turi. Let me find Turi here. I'm gonna send you here on the chat, and then you can put on people's screen on the stream.
Perfect. Yeah.
This one here. And yeah, and the branch running WebAssembly is on the pull request that's open for WebAssembly.
All right, there's the link.
So yeah. So this is the link I'm gonna put here on the screen too. It's actually useful here to have this view. Oops, let me just open. Oh my God, something is happening here. I click and goes up. Just refresh. Awesome. So here you can see the background has a bluish background, and on front you have kind of a vignette, a black vignette here. So for this effect, I used something that was kind of work in progress. That's why I had to remove for the WASM demo, because in terms of performance, and that is a mesh gradient. So I was using a mesh gradient for the vignettes and a mesh gradient for a dynamic background. Yeah, so last year, this was kind of something I had work in progress. But recently, this year, I managed to publish finally a package with it. It's called Mesh in PubDev. And yeah, it's free for everybody to use, open source too. And basically, this is a library for mesh gradient. So mesh gradient is just another fancy name for things, for beautiful things you see on the screen. And the first time I heard about this was actually middle of last year or the beginning of last year. Luke Pighetti did a kind of a nerd sniping on Twitter, and he showed, well, there is mesh gradients. Who can implement this in Flutter? And the first thing I thought was, what is a mesh gradient? And it's a big problem, because I don't think there's a consensus in the whole world on what is a mesh gradient. It's what essentially consists on a gradient that can be called a mesh gradient. So on Flutter,
Well, I'm excited that we're going to resolve the question today.
Kind of. I will show my interpretation of what's the mesh gradient. I see on Flutter, when you are using like the normal widgets and everything, and you want to put a gradient on the screen, you either have like the linear gradient, radial, and the other one is swipe. Forgot the name. It's the third one that most people don't use. But yeah, you either have those gradients, and what makes a gradient in terms of color? It's basically you have two ends, or two ends, and then you figure out the colors in between these two ends. So a linear gradient, you have these stops, we call it stops of colors, and we just the framework has to figure out all the colors in between those points. With a mesh gradient, it's kind of that, but not on a line, but on a two-dimensional mesh.
Yeah, so this is perfect, because I was just about to get in. I wanted to ask a question here. I'm not an advanced game developer, but I'm aware of meshes in games. And first of all, not everyone in the chat or that ever watches this video will be aware of meshes in games. So why don't we talk about that? And then, is this the same, or are meshes here something different?
It's different. When you talk about games, most of the time we're also talking about 3D, right? So when you talk about 3D, you are mostly talking about meshes. And meshes is basically how every 3D object is built, essentially. So it's a kind of a collection of points in space.
It's the points on all the triangles that make up the thing, right? That's the mesh.
Yes. Yes. Let me try to show some nice image here to do. Yeah, probably this is a good context. So yeah, so when you talk about 3D stuff, you're mostly talking about this collection of points in a 3D space. And with these points, you create the most simple type of form, which is a triangle. And these triangles together create this composition of things that end up being a 3D mesh. But also meshes can be two-dimensional. And I think a good example of this is, let me see, I think on 3JS plane geometry. Let me see if I can show something like that. Yeah. So I think this is a good example to contextualize a little bit. So you have this, this is like a plane mesh. So you have points everywhere here on every vertex of these triangles. And cool, we have a mesh over there, but what means that the colors can interpolate in between those interpolate in over the mesh. So we can just say that instead of on a line, that what happens on the linear gradients, we put colors on the vertices of those meshes, and then the framework, the handler, will figure out the colors in between. So,
question. Yeah. You mentioned earlier about how typically a gradient just has stops.
Yes.
And I expect most folks here have wired up a gradient and specified the stops before, but if not, that's the percentage of the way through the space that the gradient should cover and so these are now milestones. You might say it might be 0 and 100. It might be 20 and 80. You can pick any, and it doesn't have to just be 2, but these are milestones through the space, and you specify at those milestones what the color should be exactly. And then, like Hanan is saying, it figures out in between. Now, here we're talking about doing this on a mesh. So that's like just like a toe. Is it basically safe to think of this as just like stops in a linear gradient, but the order is wonky, and so then what that turns into at the end is harder to predict, but that's what this whole technology and framework does?
Yes, in a good summary, that's it. So yeah, just to put some visual representation here. So this would be like a linear gradient. You have one stop here, another stop here, and another stop here. All right, and these 3 points, you have a line. It's kind of wonky. I'm drawing with my hand here. Bear with me. And what happens, the color interpolation happens in between these points. So if you have blue here and you have red here, you're going to have some kind of shades of purple up until you reach full blue. So the closest you are to this stop, you are more affected by this color. The closest you are to this stop, you're affected by this color. And the closest you are to this, and there we go. We can have like lots of stops in one line, but the thing is, we are interpolating in a line. So this is a linear gradient, right? But things can get funny. If I go, can I undo here?
Typically that's Command Z.
Yeah, it's not working.
Boo.
Boo. Oh, it's working now. Lovely. So here we're talking about a mesh. So basically, we are interpolating in triangles. What's happening here? We have one stop here, another stop here, and another stop here. So with this, you have a triangle, all right? And you will interpolate the colors inside of this triangle, given the distance to those vertices, right? So if you are really in the middle, you have the equal amount of color of all of these edges.
Okay.
Yeah, it's really cool. But well, we'll see this kind of mesh here or this this kind of mesh here, you'll see actually you can see squares rather than triangles, right? But yeah, you can create any kind of form with a triangle. So just 2 triangles you use to create a square. So if you want to interpolating 4 points, just add another point here. You have a new triangle, and then you can create a 4 points gradient in this space, you know. So this is how a mesh gradient works, but that's not all, you know. Okay, so let me show a little bit of the prototype that I wrote last year. So yeah, I never showed this before in public. So basically, this is all Flutter, by the way, and it's a prototype of that library that's published. But basically, you have a mesh here, as you can see with these
That's
lines.
fun. That's
Yeah,
fun to look at.
yeah, I can't zoom in. It's a problem, but we'll see zooming really soon. And then you can set colors to vertices. See? So you have these
Oh.
vertices over
So
here.
right now it's interpolating between the color you set and transparent for all the
Yeah,
other nodes that aren't set.
it's not transparent. I set some kind of purple here. You know,
Oh, okay, I see.
let me show color pickers, and I'm gonna put
I thought that purple was just the background, but I see, yeah.
yeah, I'm gonna put 4 colors very different from each other here, so we can see the interpolation happening. Yeah, but all right. So what's going on here? Let's reduce this thing that's called tessellation. I'm gonna explain in a bit. What's happening here? We have triangles, right? Let me show mesh. Okay, so here we are. This is the simplest form of the mesh. We have basically that same idea actually applied on Flutter, and on every vertex we put a color. Okay, so what's happening here is we have points, coordinates in a 2D space, 2-dimensional space, and we are just for every pixel we are figuring out what are those 4 edges, that 4 vertices that I have to interpolate in between. So if I'm on this area, what's interest to me is these 4 colors. I put another color here just to make sure they're all different.
Yeah, now they're more different. The
Yeah.
top 2 are even also a little similar. Someone in the chat was pointing this out as well. It said 4
Okay.
colors. Oh yeah, super different.
Okay, let's go. How about now? Is it better?
Oh, this is great. I love it.
All right. So yes, and you can have colors on all of these points, and also colors on the actual 4 corners of this mesh. So this is a mesh gradient of, it's a mesh of 5 vertices by 5 vertices. So obviously 25 segments of a mesh here. But this is kind of ugly if you distort, you know, the colors, it's not the best. Let me just hide the mesh gradients, hide everything. If you distort, things are not funny, you know, it's kind of, there's some glitches happening here. You can see the triangle,
Yeah.
you
Yeah.
know. Yeah, so there enters Bezier distortion. So basically, you can tessellate the mesh, and the tessellation of the mesh is basically subdividing what would be like one segment into multiple segments. So every 4 vertices is one segment, but if I tessellate here, if I drag this around, it will subdivide that. And you can have loads of triangles, but there's the performance stall. And this was the problem with this prototype. The performance stall of tessellation was way too much because we are doing this on the Dart side. We are doing the vertices on the Dart side, but the color interpolation is happening with fragment shaders. Yeah, but this first implementations had its problems. I actually created this for my talk on the fragment shaders for FlutterCon in Berlin last year. And yeah, you know how side projects go, right? Sometimes they just have lots of things to do. I work for a to-do list company, and that's a very convenient thing because my to-do list is amazingly big. I have way too many things to do. So this sat in the corner for a couple of months, but something happened this year that made me work on this again, and is that the folks at Apple released a mesh gradient implementation for SwiftUI, and I was like, no way they did that, you know.
Now,
And
why is that a no way? Why did that surprise you?
because I didn't hear about anyone working on it, on actually achieving something like this on declarative UI framework before.
Okay.
And then they just released it, and was I went to look into how things worked, and I was amazed because it works. It's basically just like this, but of course with way better performance. And also even the glitches, like if you put the mesh to fight for the Z index, glitches will happen here. Let me hide the mesh. You know, weird things will happen here, and even those bugs would appear. You know, I was like, okay, interesting. But
So Apple's
I'm not accusing
implementation has the
anyone of
same thing.
anything. Sorry.
Apple's implementation has the same thing if the triangles overlap.
Yes, that if you have a overlapping of triangles, you will see some glitches depending on how you drag things in a very specific way. But yeah, super annoying. But I'm not accusing anyone of copying this by any means. I didn't even release the code, so the source code was not available, and there was no way. But
makes it hard to copy.
Yeah, great minds think alike, I guess, and they released something that's was usable, but was on the iOS beta. So I thought, oh, I can do this for Flutter. And I can even take some lessons on their implementation, how the API should look like. And yeah, so there was some fundamental problems with this prototype, which is basically I had to have 5 by 5 vertices. Can you guess why?
Nope. Other than performance, which you already talked about.
Yeah, no, not actually. That was basically Flutter fragment shaders. They have you need to have a finite amount of uniforms to pass. So basically, fragment shaders they need to know all the parameters they're going to receive. You know, I cannot pass an array of an undefined size. You know, so I need to pass the colors. I need to pass the coordinates of these colors, and then to create the interpolation. So of course I need one file, one fragment shader file for 5 by 5, another one for 3 by 3, but the implementation of mesh gradients for SwiftUI, for example, allows you to specify any width and any height of the mesh you want. So it can be 3 by 2, 4 by 12, or things like that. I cannot have one shader file for each of these implementations. It doesn't scale well.
Right.
So then I started this final version of mesh gradients that I called OMesh. It's kind of a name thing. It's actually the ended up being the name of the library, you know. And I want to do this right now. I only have for Flutter, but I want to create runtimes for this in every possible framework out there, including SwiftUI, because there's some differences here. But yeah, it's so I went to build this from scratch. So first I started for this. This is probably one of the first things I wrote. So yeah, it should be how this library should be usable, and how people could create mesh gradients in a very flexible way. So basically, we have vertices, and we also have colors for each vertex. So people should be able to pass any width and any height, and then declare the coordinates, and also the colors for each vertex. And the library will do the rest, you know. But there are, of course, other parameters that it can pass. And
How
in
are
the
you
end, it
getting
looks like
past
this.
how are you getting past the uniform?
Yeah,
That's really mesmerizing. How are you getting past the limit on parameters to the shaders?
that's when things get funny. I should show the code, but I'm going to explain first how this goes. So let me press this button again, because I am not going to press Command Z again. All right, so see how fun mesh is? It's just basically a rectangle of
Yep.
points. So let's suppose here we have a 4x3 mesh, all right, with the points not very distorted. I mean, imagine they are straight aligned.
Yep.
No,
Yep.
with this, yeah, we use the imagination now. So I cannot cover this whole thing with a fragment shader because of that problem. I could I could write some kind of shenanigan to go around this on GLSL, but from what I tested, I reached the point it's I cannot go around this.
Yeah, you could
So I
always do
cannot
like bit packing or something crazy, but
yeah.
maybe that's just too much.
So what I do on this is, well, let's do by parts. So every segment, I first go through every segment and I cover each segment individually with a fragment shader file. So in this case here, we're going to have 6 segments, each being covered by one fragment shader. And this is interesting because you can always presume that you're going to have all the corners with 4 colors always. And the only thing that this fragment shader does is figure out the colors in between, And
Okay.
doesn't even need to consider triangles here, because on GLSL we can only have like 4 points and then interpolate between these 4 points, and that's it, And with that, you have in the end, by stitching together these segments, you have one full image of all the colors interpolated, and that's
Now,
it.
you made you hand waved. I'm not really sure how to say that.
Yeah.
English is a funny language.
Yeah.
You dismissed a big gotcha, which is that the points are not necessarily in order. And as I've been following along here, listening and just imagining what my naive implementation for any of these things would be, my first thought was basically this for how you could get past the uniform limit, which, by the way, just shaders, right? They're technically programs that run on the GPU, but you can also just think of them as a function. And by the nature of GLSL, there's a maximum amount of parameters that you can pass to them. So then but then as I thought more about what the full implementation would be like if you did kind of carve up the space and have kind of sub shaders running, each point has to figure out which quadrant it's in, which is trivial if the points are all in a line, and I imagine not so trivial otherwise. And I was expecting that math on a pixel by pixel basis could only be run performantly in the shaders, which is then why the shaders were not, why the space was not being carved up into multiple shaders. But now you are doing that. And so now I don't know how you would get past that problem if these points are all scattered.
Yeah, I'm gonna try to show some code here. Obviously, this is it's a lot of things happening. This whole library, it's a result of months of weekends lost for this. So the code here is directed to performance. So things you will see that I'm doing there, it's sometimes just a smart way of pre-caching memory of anything. There are more trivial ways of do the algorithms, like this algorithm I just explained of stitching together, but they're not as performant. So I'm going to try to reason over that. So basically, that's kind of the declaration I just showed here for this mesh gradient. And what's happening here? We have a widget that's called home mesh gradient. And there's this object that's called the mesh rectangle. So this is one hint of the future of this package. I have a rectangular mesh right now, but we could have more different forms of meshes in the future. But for now, it's just a rectangular one. And I have the tessellation factor here, which basically does the job of this slider over here.
How small the triangles should be. Yep.
Exactly. And the smallest possible value here is 1, in which this case there's no subdivisions at all, and will be something like this, and well, this object's like immutable. It's just a data class with all different internal computations and lots of documentation. So if you're gonna try to use this library, I really recommend seeing the API documentation, because I put a lot of information there of how to use things and how to use all the other things. And there's some other optional parameters that we can look into later. But the one I'm really want to talk about is probably really soon is the color space. But yeah, and then there's the widgets. Let me go back to basic.dart, close everything else.
Quick question here.
Yeah.
Oishman is asking for the link to the visualizer software. Is that publicly deployed?
Yeah, so this is the example app. It's public deployed. Let me try to find the tab here. I have so many tabs. It's omesh flutter, omesh-flutter renan.gg.
And this is where someone could play with the tool and the sliders and move the gradients around.
No, this one is unpublished because it's the terrible version from last year. I was just showing because I still don't have this mesh visualization in the new one, and it's pretty useful for all of this. But you have something better, which is the editor, which is the playground actually. So I think the best starting point is the mesh on PubDev, mesh package, just this. And you have all the links on the README, including for the playground and the example app and everything. And my Twitter, where I publish lots of examples and other things, But this is much better than that, because you can have, it's a new implementation. You can adjust the size of the mesh, the widgets, and the height.
Oh, it's fun to see those points kind of wrap and unwrap as the number of nodes goes up and down.
It's a nice animation, right? It's just the magic of Flutter intrinsic animations. But yeah, you can have like customize the size of the mesh and customize some other stuff, and each individual color too. This is much better. It's also on the README link there. I really recommend if you want to toy around with this. But I wanted to go later to the editor, because I think this is like the most. It's like the end point of the whole experience, But yeah, so the widget works basically. It's a wrapper around a fun custom painter. I forgot the name of the API. Jesus. And what I'm doing here, it's like actually the custom painter is pretty dumb. What I have is what I call the omesh rec paint, which is also just an analogous of the paint API we have for Flutter Canvas. Just you can paint some mesh gradients on a canvas. And this is where the fun things are happening. I'm caching a lot of values in between paints, just to avoid avoid to the maximum the number of recomputations we can have on frames. So we can so this way we can have smooth animations even on lower devices or lower end devices, and even Canvas Kits Flutter Web. And yeah, so what's happening here? Let me recall a little bit. Yeah, so basically I divide the mesh in patches. So this is basically the segments of the mesh gradient, and I just create a shader paint for each of these. I'm just jumping over a lot of code here because there's lots of optimizations, but yeah. And here I created a shader. Actually, I pre-cache shaders, because shader you cannot reuse shader objects in the different segments. This happens. This is causes a bug on Flutter on Flutter Web, where I think something happens on Canvas Kit that only the last segment is taken in consideration, and all of the other ones will look like the last segment.
Oh,
yeah. So I think if you reuse the object, there's some moments where Canvas Kit paints everything, and will only consider the last values given. So that's why here it's like it's a basic logic for create fragment shader from one fragment program.
So real quick, I have to do my due diligence here and ask you: have you filed an issue for that?
No, because it's actually, I think it's expected behavior. It's on the documentation that's saying that you shouldn't use the same object for different paints or paint different parts of the screen.
And the object itself is just a compiled version of the shader. So it's not terrible to have more than one of them,
No.
To like compile it n times, right?
No, it's just here you have as many shader objects as you have segments.
Yeah.
And you will not recreate, because of this logic I created, you will not recreate in different paints. You'll not recreate on every paint. It's just once.
Just some compilation shader jank, NBD.
It's actually really fast. It's actually really fast.
Nice.
I didn't see any jank here. You only have the jank when you are compiling the program. So, but you can you have a loading, just like you would have on an image. You have a loading logic. But from what I could say, like if you go for this example app here, mind you, we're running on Flutter Web, and refresh, you'll not see loading screen here, right?
Right. Yeah. No,
or even on the most complex one, right?
Let's see. Snappy.
Yeah.
So, question for you, and I don't know if this is too early for this question, but you're showing some examples here of these really whimsical gradients. Yeah. These just they're giving like Mac OS, backgrounds over the years.
Oh, yeah. Like just my background here.
Right. And is that the kind of stuff you use this for, like whimsical backgrounds? Where are you deploying these tricks? What all do you do with them?
You mean usages for mesh gradients?
Yeah.
Oh, yeah. Mesh gradients are everywhere now. Especially with this AI boom, everybody's putting gradients on everything. You could put this on masking on a text. You could people are using mesh gradients for fancy homepage effects. And you could use, for example, on that Turi the demo that I showed, could use for games. If you want to create an sunset effect, for example, that actually animates, or a dynamic sky. You could create with this 2D or 3D games. They're just the imaginations is the limit. You can use for buttons. You can create Aurora Borealis effect with this. Or you simply want a 4-point gradient, not a linear. I want a 4-point gradient. Something as basic as that is also possible. Right. So you don't need to have to do something really, really complex. But the possibilities are, like the limit is your imagination, And I think this is important to be like this and not just a JPEG, because it can be animated, and you can animate with your layout, with your application constraints. So let's say I want to animate this just like we're animating here, like nonstop through time, because it's using animation controller. Let's say I want to animate this through scrolling. So I want to scroll as the user scrolls. I want to change this gradient. It's a possibility, or just as you hover, there's something, and you remove hover, it changes the state. It's also possible. So this is an example of an intrinsic animation where you press distort, and you can see a value changing here.
That's cool.
We are basically changing one value here. It's called distorted. And when we press the button, we toggle this Boolean with set state. And this uses a different widget that's called animated mesh gradient. And I pass a duration. I can also pass animation curve. And calculate the coordinates based on the distort value that's being calculated here.
Yeah. There it is. Okay.
Yeah. So
by the way, there's a user of your package in the chat, Dario. Good to see you, Dario.
Oh, Dario. Yeah, he's a contributor too. Thanks,
So
Dario.
Speaking of using, this is my next question. Let's say I'm convinced, and in something I'm working on, I've just got to have this, which obviously everyone is currently having that thought right now. How do I actually get to figuring out the points and figuring out the vertices? Is your tool what someone should use?
Yes.
How do I do this?
Okay, depends on what you're doing, what you want to do. Again, you don't need to do anything complex. You can do basic stuff. Do you have any setup there ready for a Flutter create? We can just simulate a creation here.
Oh yeah, I can do a little coding if you would like.
I mean, it would be awesome. Because I figure I never used this before, so I would have feedback too on how to use this package or what I can improve in the developer experience.
Yeah, let me create a project and then I'll pull it up here.
Awesome.
I wasn't expecting to type today. I thought I was on Easy Street. I thought I got to be a lazy bum. All right, so now I'm going to go to this one. This is what I want. There we go. Look at that. No, that's not what I want to do.
People are still seeing my screen.
Yeah, and that's not going to be a good way to share my screen. I'm just going to need to present my screen. That's what I do when there's a guest. Share screen, entire screen, this one, share. Screen, get in the game. All right, I don't know if this font is big enough yet, but I've just, I should have done create empty. I'm going to restart this. That's better. Almost want empty to be the default. Raise your hand if you want -- empty to be the default. Because I do. All right, that's one hand.
Show hands
now. So you said change screen. I think I'm on the right screen. Let me know.
Awesome.
If I'm doing something wrong. All right, so
I think first step would be try to launch this.
Okay. Oh, it's just mesh, not meshes. It's currently going to launch on my phone, which will not be terribly helpful for our purposes of seeing it. So let's do it on the old macOS.
Lovely.
Sure is how you pronounce it. Okay, so you said yes, we do use the tool.
Yeah, we can just first try to design with code, which is possible.
Oh, okay. Sounds wild.
And we can also then go to the editor and generate code from that.
I love it. Can I put in a feature request? I saw a lot of not fixed width fonts on your site that were showing code.
Oh, really?
And I said to myself, I said, huh?
Fixed width. Oh, for the colors, for the code snippets?
Yeah. All right, we're up and running.
Yeah. Awesome. So we can remove the hello world, put like a square of 300 pixels by 300 pixels or something like that. Just an idea.
Just what I thought you were going to say. Okay.
Awesome.
And what for the child?
And then we can put a mesh gradient there, but you need to install the package. You have the package installed already, right?
Yes, I installed mesh, but not mesh gradient.
Yes, that's it. So you can use I think the name of the widget is mesh gradient. Yes, this one.
Okay.
And the only required things there is the mesh. So let's put a mesh rect, because it's a rectangular mesh gradient.
You love to see it.
Yeah.
Okay.
So how many vertices you think you should have on this one? The more you put, the more you're gonna have to write.
Okay. What's the minimum number?
2 by 2.
Okay, so 4.
Yeah, so 2 width, 2 height.
Okay, and then so this is the list of vertices, I guess, right?
Yes, yeah. So
Right.
here we can use a nice notation that's via records on Dart. So basically, you put 2 numbers between parentheses.
Sorry, I'm just bothered by the error we're getting here. Oh, is it that const is up here? Oh, yeah.
Oh,
Okay. All right, sorry, I missed
very
everything you
well.
just said.
Yeah, you can put to pass vertices coordinates. You can use records. So if you pass a record of 2, you've passed a record of 2 numbers. Doesn't need to be even double. Yeah. So this is the fun part. This is the coordinate, and it's normalized. So 0, 0 is top left. Yeah, top left. Yes, and 1, 1 is bottom right. Anything below 0 is outside of the bounds. Anything above 1 is outside of the bounds. And then you do on the record .v, that it transformates into the instance of vertex.
Cool.
Yeah. The second one, this is the top right. So it should be 1, 0, I guess, right?
Oh, wait. Oh, we're going to go I see the whole thing.
Yeah.
Then. I was just going to put random spaces in.
Yeah. Oops. I think it's distorted there. This is going to be distorted because it's XY. So we have to follow a logical order on vertices here.
Do I need to do this?
Yes, from top left.
Okay.
Top down.
Got it. Got it.
Yeah.
And when once this is running, we'll go back to the other order and show everyone what it was gonna do. I'm even curious to see how that would render.
Yeah, it's very, very flexible, even flexible for you to break things. It's gonna break a little bit, probably. So we have colors, and you can pass a color for each vertex. But if you don't wanna, you can just pass null to one of the colors, and then it will use a fallback, which is like a transparent color here, but you can specify the fallback. But let's for this example, let's just pass this for, right? And I think they should run it. Yeah.
Holy smokes.
Here we go. That's it. And if you want to toy around with the numbers of the coordinates,
I do. In the words of the greatest Star Wars character of all time, now this is pod racing. All right, let's put this in.
Okay, I don't know if I agree with you there, but that's
I was not expecting this. I was expecting the center of red to move to this point, but the square to stay, the overall shape to stay square. This is cool.
Yeah, if you move 0, 0 to 0, 0, the vertex, the first one.
So this was the distortion that you mentioned. Yeah. I put these back in the wrong order.
Yeah, so if you put tessellation 1 on the widget, you will see, like, without curves, the actual mesh being started. I think it's on the widget. It's not on the rect.
Okay. There we go. 1 is so wait, what's the default value there?
The default is 12. It's just a number that I figured that this is not going to break, because the bigger the number, the worse the performance is when you are animating. The lower the number, the worse it looks. So 12 is like a nice balance
I see.
for most cases. But you may want to increase if you see artifacts, and you want to decrease if you see performance problems.
Gotcha. Okay. Dang, this is sick. I would
Yeah.
not know how to wire this up without this package.
Yeah. And there's, remember I said about the Bezier distortion? So basically, that's what we see when you have like a tessellation above one. So you can see the curves. And this happens because there's a built-in distortion on every vertex
Where do we
that
see
you
the
can
curves?
customize. You can see now because the tessellation is 1. But if you increase back to 12, you will see.
Oh.
Yeah. So there is, if you see the line between the first vertex and the second one, which is top left and top right, you see that line? That line has some kind of a curve.
Yeah.
So you have counterpoints for this Bezier distortion, and you have implicit counterpoints on every vertex, but you can customize them. So if you go back to the code, and after the first V, you put dot Bezier, and then you put this one. So this one is on top left. So the Bezier you want to control in relation of the top left is the east counterpoint. So if you put east.
Oh, okay. All right.
Yeah.
Interesting.
And then you pass another coordinates like
vertex. Okay. So I have no idea what to pass here.
0. A good number would be like 0.5 and 0.25.
Now, why those numbers feel like I have no idea.
Yeah, so the counterpoint here, it's gonna be in the actual center top. Did it work? Did it do anything?
Well, I think it's slightly less. I'm not sure. I don't know.
You can extrapolate the 0.5 a lot.
I'm gonna run this in. No, actually, what I need to do is just split the screen real estate.
Oh, that's a good idea.
Okay, here we go.
You can extrapolate. I think I was too conservative.
Oh, it just moved a little bit.
Yeah. Let's be a little bit more radical with the numbers.
Okay.
So if like instead of 0.5, go like 1.
Okay. And
0.25, the same Y as the
2.5 or 5.
Oh, that's awesome too. Anything. Actually, it's your call.
Whoa.
Yeah.
All right, that did something.
So we're just
explain
a lot of things.
So this is east. So obviously east is to the right if you're looking at a map. So it makes sense that from this point we're controlling something to the right. But like these numbers here, it's 1 and 0.25 what?
So it's a normalized coordinate system. So 0, 0 is the top left of the container. So the square that you put on the size of the box there with 300 by 300, 0, 0 is top left.
Yep, so right here.
And 1, 1 is bottom right. So you'll see the last vertex you put 1, 1. It's the green one. It's actually located exactly there. So if you change that to 0.9 on the y-axis of the last vertex, you will see that the green will go up a little bit and you just start.
Right. Yep.
So
sorry. The thing that I'm wondering is like, so this is a point in space, but what is that point in space? What is its impact on the curve? Is it like pulling the curve toward that point in space?
Yes. Yeah. So it's basically Bezier counterpoints. Then let me see if I can see a Bezier.
So that control point is kind of like right where my cursor is, right? All the way over for X and a quarter of the way down for Y.
Yes. And also the top left corner, the top left vertex has their own counterpoints too. So the west one of the top left, the top right, the west one is also impacting this curve.
Okay.
Of the top
right. But those are just on default values.
Yes.
Interesting. Now there's a bit of like kind of
Yeah.
need for some anti-aliasing.
Yeah, so this is the tessellation. If you put 100, probably gonna not see this.
Okay, I want to check that out.
Still seeing that?
Okay, I think it reloaded. I would say no change.
Oopsie doopsie. Yeah, it's probably impeller, I guess. I don't know. I have to figure that out later.
Okay. All right, but still cool.
Yeah. Yeah.
All right.
Interesting.
So now you were saying that the 0 point is also being impacted by the parameters I didn't pass, north, south, and west. Is that correct?
Yes.
Did I understand
So
that right?
since this one is on the top left of the mesh, north and west won't matter, won't affect anything, because there are no other vertices in these directions. But south and east, this one has.
Okay.
You know?
Okay.
And you are on a very simple mesh here, but you could have meshes with points in the middle, for example, in which all of the 4 points would matter. You know.
Right.
And this is how it will affect what you wanted, I guess, for to change the impacts of red in the overall file, right? But okay.
Oh yeah, there's a lot more red.
Yes, this also affects the color interpolation. You know.
Okay.
But all of this is easier to visualize with the editor. But coding is fun, but the editor is also it's also great for that.
Yeah. So this is where someone like me would just pick random numbers until you get a rayfish and not be able to recreate it or explain it at all. But yeah, so there's, can I make it bend outside? I mean, probably not because the sized box is going to clip, but can it
I'm
ever
not
expand?
clipping anything there, but yes, you should be able to. Yeah.
So if I gave like a negative value for some of these on the Bezier curve, what would happen?
Yeah. Let's see.
All right, so it does go outside, but it
clipping.
clips. Yeah, that's fairly expected. All right, well, that's fine.
Clip? I would love if you could not clip things with the sized box.
Yeah, so we could.
I may have added some APIs for this. Let me see.
I mean, I don't think it doesn't seem like an issue of the package, right? This is just Flutter, sized box, like the render tree is not giving any more space, and then it's being clipped out. I don't think it has anything to do with the package.
Oh yeah, one thing that we have is we put a repaint boundary there in the widget. We may want to remove that if you want to. There's an API for that, sure.
I don't think this will change.
Yeah,
what
not,
draws.
Not in this case. Not in this case. But if you are animating with the animated mesh gradients, that's really important. Can impact lots of things. And also tessellation is way
it's important
too high.
To have it or to remove it.
Depends on your condition. If you are on a context that you don't want to repaint the rest of the screen, set it to true. If you want to control your own repaint boundaries, then you just remove that and you control the repaint boundaries.
So the default value is null.
Default is true,
which turns into true.
Yeah.
Okay. All right. If anyone, repaint boundaries are interesting. You almost never need them. I have to represent Jonah, the aforementioned engine and graphics person on the team, by saying that if you'd like a deeper dive in repaint boundaries and how they work, I walked through it a bit in a talk I gave quite a while ago now at this point, the life cycle of a render object, which gets into the layer tree and repaint boundaries, and that really demystifies what they do. Sadly, it doesn't really fully demystify figuring out whether or not you need one in a given place. You really have to put your thinking cap on and work through it yourself. But anyway.
Absolutely. Okay. One thing I would ask you just before we go, this is an example of a more complex mesh gradient. I sent you a link. If you could copy like from the first file, there is a code for a mesh gradient rectangle.
Yep, grabbing that.
It's called album cover.
Oh, I like it. And should I copy the colors as well?
Yes, if you could copy the whole object, it would be awesome.
Oh, I see. Yeah. Right.
Well, that makes sense now, don't it?
So I'm going to paste this from here down to here.
Okay.
Awesome. If you can pass on the mesh, there's one missing parameter. I guess it's a background color. You can pass black as a background color.
All right, and that goes on the gradient or the rect?
The rect. And
wait, you've had this. We've seen this graphic. This is like your background, right?
Yeah, it's close. This one, the one I have on my background, it's a little bit more complex, but it's just a variation of this. So this I wrote before I had the editor. So it was just by toying around with numbers and code. And it was a very interesting experience. But yeah, in this case there, you see on the first line, we don't pass any color. We just go to the fallback color, which is transparent. That's why we pass in the background. And then in the middle, we just, the middle rows, we just set some nice colors over there. Yeah. But this one is interesting because it has a lot of difference on how it renders if you change the color space. So if you go to the widget, if I'm not mistaken. Oh, no, it's a rect, sorry. The rectangle. If you pass color space.
Oh.
Yeah. And then you have this enum with some built-in color spaces that we can toy around. So in this case, you can pass linear. If you pass linear, what it does it do anything?
And yeah, which one's the default?
Default is lab.
It expanded quite a bit.
Yeah, so this color spaces basically dictates how the fragment shader is going to calculate the colors in between. You know. Oh yeah, you can go around if you set the fallback color with XYY. If you set the fallback color with 0, 1, 0, 1, 0, 1. 1, 0, 1.
And then what alpha? FF?
FF, yeah. Yeah, this color space cannot handle complete zeros. Is it working?
I don't think anything changed.
Oh, that's annoying.
Yeah, seems the same.
Oh, shoot. Am I missing something?
Should the background color be something different?
Yeah, let's try that.
Actually, a lot of the stuff is red there. Let's do green. This will be hideous.
Yes.
Okay. That did work, I think.
Yeah. Oh, yeah. I think the problems are on the colors themselves. I don't know. Let's see.
I think the fallback color was just so close to the background color that it was not apparent. But there does seem to be some fallback color happening and obviously background color.
So this color space XY is a little bit different to the others because it cannot handle complete zeros, like complete blacks. So that's why we have to at least put 1. It's also on the documentation of the package, like the troubleshooting. You can learn a bit. But the XYY is my favorite color space by far. You know.
Oh.
But you have that shenanigan.
Wait a minute.
And the lab is
XYY, and almost nothing changed. It didn't go back to what it was before.
Oh, really?
Yeah. Look.
I'm gonna watch restart.
Yeah. No, did not go back.
Oh, so this is okay. The fallback worked, but didn't work with hot restart. Hot reload. Sorry. Okay, this may be a bug I have to address with hot reload. The compose method.
Yep.
I'm gonna put on my to-do list. So yeah, this is what I wanted to show with color spaces. It's pretty fun. But we can go to the editor now if you wanna. And
yeah, sure. So is that linked from your GitHub?
Yes, it's also linked from the package README. Or I can just send you the link here. It's on Mesh Playground.
Oh, okay. Sure. Yeah, send it.
A
And I'll
private
also put it in the
chat.
chat for everybody. Oh, yeah. This is the link that we've been looking at.
Yeah.
Into a banner it goes. So I'm currently going to visit here. And now I will actually do that.
Yeah.
All right.
Here we go. Then
We're
for
in.
the first thing you see there, it's a pre-loaded mesh gradient, and it's kind of a variation of that one I just showed you. Oh, there's some bugs happening. Oh,
Yeah.
shoot.
All the text
This-
is dark on dark.
This is probably WASM stuff. Yikes. I have to report to the team. Oh no, it's me being a weirdo with dark modes. Yeah, I have to change that. Do you have any known WASM compatible browsers over there? Or I can show you here.
Oh, WASM incompatible?
Yes, I
Actually,
have to
don't
fix
think I
that.
have. Yeah. Do you wanna just drive for this?
Yes, I can drive this one because I use Firefox. Can I say this in this stream?
Of course.
Right. So let me just reset this. So when you open this, you will see like this mesh gradient. So this is one to show how complex mesh gradients can be. But as I said, they don't need to be complex. So let's just reset this for something very simple, like a 3x3. I guess it's a good size, 3x3. And then let's change the aspect ratio of the viewer to 1, so just a square. And you can also have like a debug mode with where it draws some dots. I don't know if it's visible on this screen. There's some dots here.
They became visible after you
zoom in. Yeah,
said that.
Yeah. I have to add more debug modes to this version. So basically, yes, we have this. We can pan around, and if you use a trackpad, you can zoom in with this zoom in gesture, things like that. And you can obviously, you can set colors individually. So this one, 0, 0. I'm gonna put a nice color. Let's see, green with lots of alpha, lots of.
Now you mentioned, we could like use this to make a sunset. That actually sounds kind of fun.
Yeah, let's
How hard
do a
is that?
sunset.
Can we do it?
Yeah, we can do it. I don't know if it's gonna look the best because we need to have sense of colors, and for that you need to be like a designer or someone with talent for colors. I don't know, but yeah, let's put yellow on top, and then here we can put some kind of darker yellow or something more to the orange direction. Maximum saturation, because I love maximum saturation. Darker. The one in the middle, I'm gonna put a little bit darker or brighter. Yeah, it makes sense to be brighter, right?
Yeah. One of the things I was wondering is like, can we actually get a horizon and the bright sun kind of near the horizon clipping?
We're gonna need a lot of vertices for that. Let's try 4x4 then. Oh, I think this do great, I guess. If I put this over here. So you see that we have these, every time I drag something, there's these 4 points.
Mm-hmm.
This is north, south, east, west, and east. And they are dashed here because they are the full versions, but you can drag around and customize their values just like in the code, or you can hold and it will reset to the default. So yes, you can put this here. Let me put this one really close and more yellowish thing, more value, and there we go. I'm gonna remove the debug mode because it's a little bit distracting for me here. And here I'm gonna put orange, almost red, maximum saturation, but really dark.
Mm.
Okay.
So is that the horizon?
Yeah, and I can make it like more more dramatic, this.
Okay.
What's the name of that guy that just had happy mistakes on the TV?
Oh, Happy Little Trees. Yeah.
Yeah. I
Bob
feel like that now.
Ross. Bob Ross. Yeah. What a delightful person.
Yeah, so you can drag things to outside of the viewport here, just like we're doing now.
Yeah. Okay.
I'm gonna
So
move around some counterpoints randomly just to create some little bit of chaos.
we need some pink in the sky. That's
Oh,
always
really?
my favorite
Okay,
color
let's
to
go
see
pink.
in the sunset.
Let's put the best color space. Here we go. Oh, I love this color space.
And pink just
XYY.
immediately appears.
Yes, interesting.
What a called shot.
Let's put this here in this.
Yeah. Okay. So this kind of highlights what the color space is doing. I mean, I'm no color wizard myself, but when you kind of returning and thinking about interpolating between this deep, deep maroon you have and the yellowy orange, like, I don't know, it makes sense that pink would be between those, but it wasn't until you went into the right color space. So color space is just the way that the hex values are interpolated, I guess.
Yes. And this is the only thing that the mesh gradient, the fragment shader is doing. The distortion and everything else is on a different API from Flutter, which is draw vertices. So we create those triangles on a draw vertices routine, and even the tessellation, and then we distort after all of the segments have been patched together. So we patched the segment as a normal image, and then we put on draw vertices and distort that. Just distort it after. So it's in this on every frame. So it's a lot of work, but it's so optimized. And Jonah opened a pull request that kind of like improved the performance for 200%. It's crazy, just by using typed data.
Oh yeah, that's always a.
So yeah, you can see
little superpower trick.
The lines in between each.
Yeah.
Thingy. So it's like it's a Bezier control points manipulation, and I think we have it. I guess. Any other idea? I'll put the dark.
This is pretty cool. I mean, if I was going to actually render a sunset here, it sounds like what I would maybe do is have all of this in a stack.
Yes.
And this would be the back thing, and then I would actually just have a yellow circle above it that would be the sun.
Yeah, but the fun thing is you can use a stack. Imagine you have this, and you want to put the text below the horizon, put on top of the sky. So you can just, set for the bottom layer, you can only pass like the sky colors, and from the top layer, you can pass only the horizon colors, and in between you put a text. This is how the image of this works. It's just a stack with the text in between. So you could do that. You can make this thing talk with the rest of your layout. And then you can export an image or Flutter code. So basically generates the Flutter code for you that you can put on your Flutter application. That's it.
Oh. Where was the export button? I was reading chat for a second.
It's in the button. It's in the button.
Export as Flutter code. Got it. Right.
Yes.
Okay.
Flutter code. And that's it.
So this is the non-fixed width and elsewhere, I think. But I'm really nitpicking now because this is a really cool package.
I have to fix this font. Okay. This whole thing, this playground, is a work in progress. There's a big problem here. If I refresh this tab, I'm gonna lose the state. And you cannot start this with one of your meshes. You imagine you created something and you want to restart.
Right.
But I'm working, and the next version is coming soon on something that may fix that. And it's basically represents the state of the mesh in a hash. basically.
Yeah.
So you could
Oh,
have something on the URL here, and whenever you're editing, you could
yeah,
have,
it'll change.
if you
So
refresh,
is
or you
it
can even share the mesh with other people.
right? Oh,
Yeah.
so share. Okay, that's. So are you going to use Bitpacking for that? I guess.
Yeah, I mean, the pull request is open. It's really, I opened like today, but there are
Ah,
lots of stuff to do. I'm using on a package of someone that's in the chat. It's called Wolferain. He created this package called Binarize, which is a nice way of formalize um, ways in which we're going to represent state in binary format.
mm,
So you have here the object, the mesh rect object with the dimensions with 5 and the colors and the vertices.
uh-huh.
We want to represent that in the binary in the most compact form possible. So you can create this kind of thing that we call payload. And yeah, just represent. But in the end, I'm just going to show this test here. I've a mesh like this one. Let me see. This one I called simple mesh, the same one as in the example app.
Mm-hmm.
I can represent and gonna look like this,
Yep.
So it's a file format, essentially, and then you can hash that using compression and things like that to create the shortest possible hash for this type of thing, and also future proof with more additions we do to the library. We won't break the hash,
Right. Cool. Are you gonna
Yeah.
throw any of those in local storage? So
We can put even on the address bar. Address bar is a nice storage option for the web, and then you can
true. I
just
guess then
copy the link. And if you open
in
with
your browser history.
and if you can even put on Twitter or things like that, and you just open, and you open already on your mesh. And you can also
Fun.
you could also even, instead of passing all of these coordinate things, but if you put on mesh rect from hash and just pass a string with, you could also do that. A string with this hash that I showed on the pull request. But yeah, it's still work in progress. I have to make this shorter. That's
Fun.
it.
Well, man, oh man, this was pretty illuminating. I am always impressed by folks who crack open the graphics layer and go a level down. That's never really been my forte, but I appreciate all of you
Yeah.
folks for whom it is your forte, so that you can release
Yeah.
libraries like this. So I
It's
can
really
use them
fun.
and not know how they work.
And now we have mesh gradients in Flutter, not only on SwiftUI, and also on SwiftUI only have on iOS 18. With Flutter, we have mesh gradients on iOS 14 if you want to. Yeah.
So a couple questions that I starred. First one from Wolfen. How's it
Wolferain,
performing on the
yes.
web?
Does it scale? Yeah, so the editor here is running on the web. Obviously, we saw some problems with the WASM support. I got a fix. I probably gonna have to update some things there, but that's a test, But yeah, the performance you can see here, it's really good. Canvas Kit has improved a lot in the last versions. The last Flutter version, I don't see any issue at all. You can open the let me open here this
Have you tried it on Squasm?
Squasm. Yeah, that's the one you saw with the issues. SK wasn't, yeah.
Ah, okay.
And yeah, so if you open here, go to the GitHub and see Mesh Flutter. You can even open on mobile. This also works on mobile, and there's an animation happening on the web. So performance is really good,
Seems pretty good.
but I'm not saying it's perfect. You can go around and put your like a 12 by 12 mesh with lots of vertices and put a tessellation 100, you're going to see problems even on desktop.
Yeah.
So yeah, just be mindful about that. And if you see any performance problems, if you're not animating, it shouldn't be a problem at all. If you're just doing a static mesh gradient, just like, would be this one. This is even better than image because you don't have to load pixels. It's just vectorial, so it should be much better than any image. But if you're animating, be mindful with the performance, the tessellation performance. Yeah.
Second question saved from the. Also, I just love this name from the original wombat. Like, this is the, they talk about speciation and evolution when there's no like clear line of when in the ancestry tree one species became another species, but like at some point when you zoom out, it happened.
Yeah.
We found it for the wombat species. This creature's parents were not wombats, but it is a wombat.
Yeah.
Anyway, what about a ripple effect?
Yeah. No, we cannot. But yeah, this is a very nice question, and it's something to do evolution for this library. You in Swift you can apply the mesh, the distortions, not on colors, but on actual UI. And we should be able to do this, but we have to sample to do the to sample the UI as the input to the draw vertices API rather than the things that we did with the fragment shader.
Oh,
So yeah, it's doable, but it's not possible right now. Figure this: you could pass a child to the widget, and instead of passing colors, you pass just a child, and then it distorts that child. Yeah,
right.
So that's how it would work.
Yeah. There's the animated sampler for that, which I'm certain you're aware of.
Yeah.
I haven't used that in a long time. The old animated sampler, which for anyone who's like the animated what alert, it takes a piece of your UI, kind of renders it on the side, and then passes that pixel buffer into a shader for further wonkiness. It's pretty cool.
Yeah. It's on this package.
Yeah. Which, even though it looks like it's the least trustworthy package in the world, is actually from the Flutter team.
Yeah, it's pretty good.
But the API is not totally solid yet, which is why it's not like formally on the Google org and all that stuff. Okay, cool. Well, hey, this is really, really sweet.
So the way it would work is pretty much like this. You pass a child, and then you have an image, then apply the mesh to the image instead of the colors. That's it.
So, Renan, any final thoughts here? I'd say we've done it.
Yeah. Final thoughts. Yeah, if you are interested anyway in this, I just say keep it up with this. I'm planning lots of additions. I mentioned some here already with the hash and everything else, but I think we still didn't see the possibilities of this kind of thing. Mesh gradients in general are very flexible, so they're nice examples that I still have to publish. I'm still working on my blog, by the way, more than a year now. But
when I was a web developer, it felt very important to me that I had a functioning blog that like I made. And now that I'm not a web developer anymore and just do Flutter, I've actually just taken my website down. My domain doesn't even resolve anymore because I got tired of thinking about it ever. And so that's how far my website has fallen.
Yeah, my problem is that everything I do on this, like in this front, I publish on Twitter, and not everybody has Twitter, and it's also not the best medium for old things. So if I myself want to revisit things I did a year ago, 2 years ago, it's such a hassle to get there. So that's why I would use a blog rather than Twitter or anything like that. But yeah, I'm still working on it. So, but I will, once it's up, I will just publish lots of examples I have already done for this.
Cool. Well, yeah, and you're totally right about all social media. It's so hard to dig into. Philosophia, great name. Talk to Brandon about 3D. Oh, that is quite a good idea. I don't know. Not everybody likes to be a part of a live stream. I don't know whether or not that sounds fun to Brandon, but that's a fun idea for sure. I do know that right now I have the next quite a few episodes all booked with guests. So it'll be a while at a minimum, but That's a great idea.
Yeah.
All right. Renan, thank you for coming back on and walking us through the bleeding edge of amazing Flutter graphics.
Ooh.
Oh, uh, yeah, no, this was fun. I had a great time. And folks, I don't remember who next week's guest is. Actually, maybe I do, but anyway, it doesn't matter. You'll all see it when the YouTube thumbnail comes out on like Tuesday of next week. But I will be around for quite a few weeks at this point, I think. So Observable Flutter should be more regular looking forward or moving forward, which I'm excited about. Thank you all for being patient with me while I travel around and see the world and talk about Flutter in all different time zones. Renan, any closing final thought? Maybe if people play with this, how about they tweet at you what they built?
Yes, please do. Yeah, if you're considering using, just ping me, and then can I help to take some doubts out. And also keep tuned, because I'm going to update the playground editor with lots of fun things.
Great. Cool. All right. Well, folks, that will do it for today. And like I said, we'll be back next week with a totally new topic, which I'm very excited about. And I will leave you all until then. Happy fluttering.
Thank you.